Bismillahirrahmanirrahim. In this session, we will discuss electrical quantities from Tom Deacon and Heather Kennett book of 2021, and this book is highly recommended for physics book published by Hodder's Education, which is very popular in O level and IGCSE community. So this book is highly recommended from examination point of view of O level and IGCSE. So that's why we are following it. And from this book on page 185 we have this question: two identical conducting balls suspended on a nylon thread come to rest with the threads making equal angles like this with a vertical as shown in figure 4.24. Which of these statements is true? This shows that the balls are equally and oppositely charged. The balls are oppositely charged but not necessarily equally charged. One ball is charged and the other is uncharged. The ball both carry the same type of charge. So this shows that the ball both carry the same type of charge. If they carry the same type of charge, they will always repel each other. So if two identical conducting balls suspended by a nylon thread, this is a thread, come to rest with the thread making equal angle with the vertical, so they makes equal angle, so they always oppose as shown in figure this. So this is best option. So they carry the ball both carry the same type of charge, so they always repel each other, so make a distance. If they have a same charge, they will attract each other. So will be here due to the gravitational field is force and which charges, so they always close, comes to very close together here at this point. In question number 2, explain in terms of electron movement what happens when a polythene rod becomes charged negatively. Polythene rod becomes charged negatively by being rubbed with a cloth. Polythene rod become charged. So polythene rod becomes charged negatively by being rubbed with a cloth. The production of charge by rubbing can be explained by supposing that friction causes electron to be transferred from one material to the other. So the polythene becomes negatively charged, means the electron will be appear on the polythene from the cloth. So in this way, because in a non-conducting material, insulators, friction is the way that electrostatic charge produce. So this is one of the way that it becomes negatively charged and the other side becomes positive. So it gets the electron from the cloth due to the rubbing or friction. So friction is one of the reasons. So here the key point is friction. Two electrostatic charges are brought close together when one charge is positive and the other is negative. Are they attract or repel from each other? They always attract. When both charges are negative, are they attract or repelled? Always repelled. So the answer is very simple. Now put this into practice. A current of 2 amperes flow past a point. Suppose in a line, a current is flowing through a point P in an electrical circuit in 20 seconds. How much charge passes the point in this time? So the current is given as a 20, sorry, this is 2 amperes, so this is wrong. So we have mistakenly write down this 20 ampere. So this is 2 ampere. So if this is 2 ampere, so this is 20. So this is 2 ampere and this is 20. This becomes 20 into 2 is 40 coulombs. If we suppose that if current is, if we make a correction here, if this is 20 amperes and this is for 20 seconds, then this becomes correct. So just omit 1 0 here, 1 0 here and 0 here, and the correction, the result will be same. So if make one correction here, this is 20 amperes here, and then this whole question becomes correct. So a charge of 2 coulomb passes through a point in an electrical circuit in 7 seconds. So this is a charge 2 coulombs and time is 7 seconds. So calculate the current flowing through past this point. So the current is always given as charge upon time. So this is 2 coulomb and this is 7 seconds. So 2 divided by 7 is this. So this much ampere current will flow through that point. So test yourself. Explain your electrical conduction occurs in a metal. How electrical conduction occurs in metal? In metals, each atom has one or more loosely held electrons that are free to move. In a metals, have free electrons. When a battery or any generators is connected across the end of such conductor, the free electron drifts slowly along in the direction from the negative to the positive terminal of a battery. So the electrons move from negative to the positive terminal of the battery. There is then the current of negative charge flows, and this is how electrical conduction occur in a metal. So electron flow from negative terminal to the positive terminal. This is called electron current, and in conventional current we take it opposite of that electron flow. So this is the answer of this question. Explain how would connect an ammeter into a circuit. Ammeter is used to measure current. It should always be placed in series in a circuit. So ammeters are always connected in a series. This is very important. And voltmeters are always connected in parallel. Voltmeters always connect in parallel, and ammeters are always connected in series because it has a very low resistance. So if we apply ammeter in parallel, it will immediately damage. So never apply ammeter in a parallel. It always applies in series. So this is very important. What is the current in a circuit if the charge passing through the point is 10 coulomb and 2 seconds for 2 seconds? So charge is 10 coulomb and time is 2 seconds. So the current is charge upon time. So 10 coulomb divided by 2 seconds. So this is 5 ampere. For 20 coulombs in 40 seconds. So 20 coulomb and 40 seconds. So this is 20 coulomb and this is 40 seconds. So we'll have this 0.5 ampere. For 240 coulombs in 2 minutes, so we have 240 coulombs, and 2 minutes is basically 120 seconds. So I is equal to Q upon T. 240 coulombs and 120 seconds, that is 2 ampere. How long does it take a charge of 5 coulomb to pass a point in an electrical circuit where the current flowing is 2 ampere? So we have to find the time for this 2 ampere for a 5 coulomb charge. So I is equal to Q upon T. So T is equal to Q upon I, and Q is 5 coulomb and current is given as 2 ampere. So it will take 2.5 seconds. So it will take 5 coulomb to pass through a point in electrical circuit where the current flowing is 2 ampere. So the time taken is 2.5 seconds. So a sketch. So test yourself, page 193. Sketch a DC current. So this is a DC current. And this is also a DC current, but this is a varying DC because the net or average value of this DC will be positive because there is no negative flow. So this is varying DC and this is steady state DC. So in an AC we have a positive cycle and this is a negative cycle. This is sinusoidal wave AC in one direction, in the other direction. Similarly this repeats and so on. So this is AC. A circuit used for AC is always this sinusoidal shape. and an AC current has a frequency of 1000 hertz. How long does each cycle last? So frequency is always reciprocal of time. So this frequency is 100 hertz. So it will take 1 milliseconds to complete a cycle. So this is basically here to here is a one cycle. If the frequency is 1000 hertz, suppose, so it will take 1 milliseconds. Now put this into practice. Calculate the potential difference across a lamp in an electric circuit. So we have to apply a potential difference across a lamp in electric circuit when 8 joules of work are done when a charge of 4 coulombs pass through the lamp. So we have given this information. We have to find the potential difference, and we have given the work done, and we have given the charge flow. So this is work done is 8 joules and coulomb is 4 coulombs. So W is equal to Q into V is the formula for work done, charge into coulomb. So this is 4 coulomb, and this is we don't know this, we have to find it. So this is known, this is 8 joules, so 8 joules, so voltage is equal to, or the potential difference is equal to work done divided by the charge. So this is 8 joules and this is 4 coulombs. So on division we have this 2 volts. So this potential difference applying across the lamp is 2 volt. So this is very important. A PD across a lamp is 6 volt. So how many joules of energy is transferred when a charge of 2 coulombs pass through it? So the PD is given as 6 volt, and we have to find the joules transfer. So this is work done or energy transfer. So this is W is equal to Q into V. So this is 2 coulomb and this is 6 volt. So the energy transfer will be 12 joules. The potential difference across a lamp is 6 volt. Find the work done when a current of 3 amperes flows in the lamp for 10 seconds. So we have this potential difference 6 volt, and we have to find the work done or energy transfer. So this is current is 3 amperes is flowing for the duration of 10 seconds. So W is equal to I into T into V, VIT, V, I and T. So this is 3 amperes, this is 10 seconds, 3 ampere, this is 10 seconds, and this is 6 volt. So we have this 180 joules. So the work done is basically 180 joules. Now put this into practice. This is on page 196. Uses the sketches of the voltmeter shown in figure 4-220. So this is voltmeter. When do the small division between the numbers 6 and 8 represent? 6 and 8. So we have this meter has basically two readings, two ranges. A lower scale range that is from 0 to 5, from 0 to 5, and the upper range which is from 6 to 10. Small division between 6 and 8 is 0.2 volt. So the small scale division is 0.2 volt. So which scale would you use to measure a volt of 5.4 volt? Upper scale, because the lower scale only measures up to 5 volt. For upper scale we have to find this value. So when we switch to the upper scale, it will move from here to outward. So in this way, because this is the difference between 6 and 8 is 2, and divide by 10 is 0.2. So that's why it is 0.2. For this we have a scale of 0.1, because 3 to 4 we have a difference of 1 and there are 10 divisions, so that will be 0.1. So this 5.4 will be measured here, because on selecting the upper scale the reading will start from 5 to onward. Which scale would you use to measure volt? This upper scale. When making a reading for 4 volt, an observer's eyes is over 0 volt mark. Explain why the value obtained by this observer is higher than 4 volt. Because of the parallax error. It may happen when making the reading of 4 volt, an observer eye is over the 0 marks. So this may be due to the parallax error. Test yourself on page 197. Define electromotive force. An electromotive force, symbol E, is defined as electrical work W done by a source in moving a unit charge around a complete circuit. So EMF is equal to work done by a source by charge. So this is electromotive force is basically work done per unit charge. Electromotive force is basically work done per unit charge. So this is electromotive force. And define potential difference. Potential difference is defined as the work done by a unit of charge passing through a component. So work done by a unit of charge passing through a potential component is called a potential difference. So the potential difference is also very close, but this is work done. So when PD across the lamp is figure 4.222 is 12 volt, how many joules of electrical energy are transferred into a light and heat when a charge of 1 coulomb passes through it? So this is 12 volt and this is 1 coulomb. So the energy passes or work done is 12 joules. A charge of 5 coulomb pass through it. If 5 coulomb per 12 volt, then it's 60 joules. A current of 2 ampere in it for 10 seconds for 12 volt. This is 2 ampere and 10 seconds. V, I and T. So this is 240 joules. Now put this into practice, page 190.